This is a Raspberry Pi, and essentially, it's just a computer. You can do anything that a computer can do, but I feel like you can do a little bit more. Since they have a lot of these pins, you can connect it using electrical wires to a specific breadboard and be able to control its output and input pins. And using that, you can build a lot of small personal projects. So whether you're a beginner or an advanced user within the hardware and software space, you can make use of the Raspberry Pi. In this video, we're going to be talking about how to make a simple project where you can connect an LED and button where you can turn the button on and off using the Raspberry Pi.
Well, initially this looks like a complicated mess. The more that you use the Raspberry Pi, the more that you're going to be able to understand it. So the Raspberry Pi is connected to my mouse and my keyboard. That's what these two, so my mouse and my keyboard. And it's also connected through my monitor via HDMI, and it's also connected to the power cable the outlet using the power cable. And to understand what this means, I'm gonna have to quickly explain how a breadboard works. The way a breadboard works is there are two strips, the blue and the red, and think about all of the blue being connected. So the blue is connected and the red is connected. The same on the other side. Then in the middle, all of the rows are connected. So in this row, if you plugged anything in to the first pin and anything to the last pin, those two will be connected. So by being able to explain how the breadboard works, you're going to be able to understand how we can use it in our example. So let me pull up the code really quickly. So as you can see, once you turn on the Raspberry Pi, it's going to open up the Raspberry Pi operating system, where you can open up the terminal. As you can see, I opened up the terminal and I connected to the specific project directory that I'm going to be using in this project today. So if I type ls, I can see the list of files within that folder. And I already created the file, but if you have not, just go to any directory and just create the file called main.py and then run nano and then main.py. And once running this command, you will see the code that will be used for this project. So with these two lines, you can see that the LED pin is already set to line 23 and the button pin is set to line 24. Those two are going to be important. The rest are all going to be copy and paste code. This will describe the logic for turning the LED on and off, but it's not important to understand it for this hardware perspective. So once you have that saved, you can save it using Control X, and it'll ask you some prompts. Save, just press yes, and then press enter. And then it'll go back to the terminal, which then you can run the command using python space main.py. And once this command is running, you can see it stops there. You can press a button and then it turns off the LED. You can press the button again, it turns it off. So let's look at how the specific wires are connected. So as you can see, the Raspberry Pi is connected to an extension pack, which you can see where specifically each wire is connected to. So at the top, the black wire is connected to ground, and it's connected to this blue vertical strip that I said is all connected. Connected to that, there's the gray wire, which connects to one side of the button, and also it connects to a resistor. It's a very low voltage. I think it's our low ohm resistor. I think it's around 200 ohm. And that resistor is connected to the LED. Then the red and yellow wires are connected to their corresponding GPIO port on the extension of the Raspberry Pi. So the button is connected to port GPIO 23, and the red wire is connected to port GPIO 24. And this corresponds with the code that we described, as you can see here. And using this code, we were able to turn the LED on and off successfully.